All right. So fine. So I hope I'm audible to all of you. All right, that's great. So welcome back to this particular session of Pradhan Academy. Okay. And if you're new to this particular channel, I would like to tell you about this is that we are basically discussing the previous year questions of JEE Mains, right? And along with the sessions we are taking, we are trying to discuss the top 10 important JEE Mains questions, right? So with this, you can try to revise the entire syllabus, and we can also try to solve the questions that is basically been asked up, right? So this will actually help you to revise the chapters in a short time and also help you to do a quick recap as well as get working on the questions, right? And these sessions are very useful for those who have already studied the chapter of limits and have done or have revised the short notes or the formulas, right? So before you start for the session, I would again like to repeat this again. That is, before you start with the session, please make sure that you complete the NCERT as well as NCERT exemplar, right? So please make sure that you complete these two materials before you start for today's session, okay? Because this is going to be very beneficial, and also it is very important before you start solving the JEE Mains previous year question, okay? Now once you're done with this, I always request my students is basically to make short notes. Okay, try to make short notes because this is going to be really useful whenever you are revising or the day before the examination. Okay, so the day before the examination, this particular thing is going to be really useful to all of you. Okay, so please make sure that you make the short notes and then you start working on the previous year question. Okay, and if you are someone who has done with this particular preparation, who has done that chapter of limit and have made short notes and have also practiced the questions, then you are ready to go or start with this JEE Mains previous year questions. All right, so I expect that you are done with that. So let's get started on this today's session. So today we are going to discuss the most important questions. Now before we start with the discussion of limits, I will also take a quick recap of the important properties and the formulas that you need to recall before you start solving the actual questions of limits, right? So that is it. Let's get started. Okay, and if you're new to this particular channel, don't forget to hit the subscribe button. Okay, and if you like this particular video and you think that these kind of sessions are helpful to all of you, then please don't forget to hit the subscribe button, as well as don't forget to hit the like button. All right, so and also what you can do, you can also click on the bell icon to never miss out any upcoming notification. Okay, because we are basically discussing every evening on some of the important topics of the maths and especially for JEE Mains. All right, so these sessions are basically keeping in mind the upcoming JEE Mains examination. And if you're from class 11th or class 12 and you have done your limits chapter, then you can start to sit with this particular session as well. Okay, all right, so with that, let's get working on this session. So today our goal is to basically revise the concept of limits. Along with that, we will also discuss the JEE Mains previous year question. We practice both MCQ as well as numerical type. We'll try to see what are the types of question that has been asked in the JEE advanced paper, especially the integer types and the single correct type. Also, we'll try to see a paper statistics and try to understand that how important is this particular chapter. All right, so let's get started. Please give me a thumbs up so that we can start. So let's get started. All right. So if you look at the paper analysis, in 2024, the weightage of this particular chapter. Now, when I talk about limits, I also try to include the concept of limits, continuity and differentiability, right? Because these three topics are connected to each other. Okay, if you try to understand limits very nicely, then these three chapters are going to be really easy. Okay, so if you look at the weightage part in 2024, the weightage was somewhere around 2 to 3 questions. Okay, 2 to 3 questions from the parts of limits, continuity and differentiability. And if you look at the year 2023, then again the weightage was something around 1 to 2 questions. 1 to 2 question, right? And if you see in the year 2022, the weightage was simply around 3 to 4 questions. 3 to 4 questions, okay? So, and if you look at 2021 paper, the weightage was again around 3 to 4 questions, okay? So this will give you a clear idea that this particular chapter is a very important chapter. Now, trust me, if you have to learn calculus in order to solve any questions of differentiation, any questions of application of derivative, it is very useful to understand the concepts of limits before you start solving on the questions. Okay, because these limits, continuity and differentiability are a very important and integral part of your calculus portion. Okay, so if I try to tell you limits in very short thing, limit is just nothing but it is a value of the function at which I cannot directly put the value of x. What do I mean by that? So for example, now if I try to illustrate that particular saying by an example, is that let us take a very simple example. Let us take a very simple example of tan x, okay, of a simple graph that is tan x, right? Now if you recall from the tan x graph, if I ask you that what is the value of tan x, so especially you know the tan x is basically the ratio of sin x upon cos x, right? Now, if I try to ask you that what is the value of this tan x at x equals to pi by 2, at x equals to pi by 2 or 90 degree, right? Now, if I need to ask you this particular question, that what is the value of this tan x at x equals to pi by 2 or 90 degree, then your answer will be simply like it is kind of division by 1 upon 0, right? Because if you look at the concept over here is that it is sine by cos, so cos 90 is going to be equal to 0, right? So therefore, your y value at pi by 2 is going to be not defined. Now, first of all, it is very important to understand this particular concept. Okay. Now, not many students know this, that tan of pi by 2 is not defined. What students basically, when they come from class 10th, or they basically have this intuition that tan of 90 degree is basically infinity. Now, there is a very important difference between infinity and not defined. That is what we need to discuss in this particular chapter of limits, right? So the question that what is the difference between an infinity or what is the difference and between not defined, that particular thing is differentiated by the use of limits. So limit will only exist when the case is basically not determinate, okay, or basically it is basically indeterminate forms. Okay, so limits will be especially need to be calculated for the functions where we have indeterminate form. So if I discuss about this, so tan x, the graph of tan x is basically like this. Okay, I hope you all know this. So this is very asymptotic at pi by 2, right? It is asymptotic at pi by 2, and similarly it is again asymptotic at minus pi by 2, right? And it is a periodic graph with a period of pi. I hope this information is all known to all of you, right? It has a period of pi, right? So this is a periodic graph, and this is asymptotic at pi and minus pi by 2, right? And it repeats after that pi interval. That is what is the graph is basically talking about, right? Now the very important differentiation to understand that why do we need to calculate limit. Now think that I ask you that what is the value, instead of asking you that what is the value exactly at x equals to pi by 2, if I ask you by this way that what is the value in the left hand side of pi by 2, means I mean to say that if I want to take the x to little bit less than pi by 2, that is from the left hand side, right? So if you stand over here, to the left hand side of your is the quantity which is less than pi by 2, and to the right hand side of you is the quantity which is greater than pi by 2, right? Now, so let me write this as right hand, this is right and this is left, right? So at the left of pi by 2, that means the quantity which is less than pi by 2, if you look at this, you will get a finite value. You will get a finite value, because I mean to say finite value in the sense that it will be a value which is very larger, right? But it will have a value. But instead, if you directly say what is the value at pi by 2, then my answer will be it is not defined. So in literature of mathematics, it said that 1 upon 0 is not defined. 1 upon 0 is not defined. Okay, because nothing can be divided by 0. But instead, if I change the question and I write like this, 1 upon 0 positive, you will say the answer is going to be infinity. You will say the answer is going to be infinity. So what does this basically means? That 0 positive means a number which is greater than 0, but very less number, and almost equal to 0, but greater than 0. So that is a simple example will be 0.000000 and so on 1, right? So some kind of number, but it is not exactly 0, it is greater than 0. It is just greater than 0. So when we divide by 0 positive or when we divide by 0 negative, the answer is, in this case the answer is minus infinity, and in this case it is infinity, right? Now the question is, again, it is not a finite value, right? It is not a finite value. So how can you tell the limit will exist? That's a very important challenge that you need to understand, right? Because limit is a finite value. Limit, whatever we talk about in the chapter of limit, it is a finite concept, right? So you have to understand that whenever you are getting the limiting value as infinite, or you are getting the limiting value as minus infinity, unless and until it is mentioned in the option of the question as infinity or minus infinity, you are going to mark the answer as not defined. And in this case, especially if you see, if you know that the graph of this at pi by 2, it is again going to be like this, right? Something like this. So if you look at, so limit will only exist when your left hand side value and the right hand side value are equal. Okay, it is not the concept that the value exactly at that particular point of x should be equal, but instead what we need to see that compare is that the left hand side value and the right hand side value should be equal. But in this case, if you look at the left hand side value, it is going towards positive infinity, right? And similarly, in the right hand side, it is going towards minus of infinity. And that is basically going to give you that the right hand limit is not equal to the left hand limit. Okay, so this is the right hand limit and this is the left hand limit. So I'm writing a LHL, that basically means left hand limit. Okay, and I'm writing RHL, that basically means right hand limit. Okay, so once you know that whenever your RHL is equals to LHL, then you will say the limit will exist, and whatever the value it is, that is the finite value of the limit. Okay, so that is called the value of the limit. All right, so I hope this particular idea was clear to all of you, right? Because this is one of the basics idea that you need to already understand before we try to solve questions. Okay, I know many students won't have this kind of conceptual clarity. That's why I'm repeating it again. Okay, so I took a simple example of tan x and I showed you that tan of pi by 2 is not defined. It is not infinity. It is not defined. Okay, so next time if someone asks you what is tan of pi by 2, please don't tell the answer as infinity. It shows that you don't know anything. Okay, so make sure that you recall this part and you try to apply it up. Okay, all right, I hope this part is clear. Please let me know this part is clear or not. Okay, I'm assuming this part is clear to all of you, right? All right, so let us assume that this part is clear to all of you. So we are basically ready to proceed, right? Because this is one of the very important and crucial concepts that you need to understand before we try to solve the questions. Okay, so in the questions, what you will see that in the chapter of limit, we are basically trying to calculate the left hand limit and the right hand limit, and we are getting the value, whatever the left hand limit and right hand limit value we are getting, we are trying to get at, that is the value of the limit. But if we just move one step forward for continuity, what we are trying to do is that we are trying to equate the value of the left hand limit and the right hand limit to the value of the function at that particular point. And if this particular limiting value is equal to the function value at that particular point, let us say that a particular point x, then it is said to be continuous. It is said to be continuous. Okay, if the left hand limit is equal to right hand limit, then it is said to be continuous function. Then it is said to be a continuous function, right? And differentiability is little bit different. It is checked by the continuity of the slope at that particular point. So if I need to check for the continuity of the slope, that is at any point, if I need to take the continuity of the slope, that is the continuity nature of the f dash of x. Okay, so for differentiability, okay, so for differentiability, we check the continuity nature of f dash of x. Okay, so now you must be wondering that why I am repeating this in the lecture of or the session of limits, because our agenda is to discuss the concepts of limits, not differentiability or continuity, right? But these topics are very much closely related to each other, right? That's why I'm basically trying to tell this part. Okay, so I hope this part is clear to all of you. Okay, don't worry, I will take the concepts or the questions of continuity and differentiability in the next upcoming sessions. Okay, so tomorrow we will have the session on continuity and differentiability. Okay, so today our session is basically focused on discussing the questions of limits. All right, please let me know if this is clear. Okay, so let us start with the very first discussion about the important properties of limit. Okay, now these are some of the important properties that basically exist for limits. That let us say if g and f are the two real functions within the common domain. Now it is very important to understand that why do we need to study about domain, right? Now for a limit to exist, that particular function has to be existing, right? That means whatever we are talking about the limiting value, now that must be inside the domain of it, right? So if it is not the question of a domain, so therefore if the function is not defined at that particular point where we are trying to calculate the limit, for example, what I'm trying to talk is that now if I have a function you have function something like x is equal to a, and the value is basically like within some value, like let us call this as x is equal to a1, this is a2, and this is a3. Okay, so this a1 is less than a2 is less than a3, and it is said that the function is starting to define, and this is called as 1. Okay, so function is defined from 1 to a1, and then again it is defined from a3 to 2. Okay, let us say it is defined like this way, that the function is defined from 1 to a1 and then again from a3 to 2. Okay, in that case, if I ask you what is the limit at a by 2, or what is the limiting value, so let us call this as a graph of the function f of x. Okay, so if I ask you what is the limit at x tending to a2 for the function, then I will say that the function do not exist, so the limit concept is not even existing, right? So therefore this is not even a relevant concept, right? So for example, for a limit to be existing at that particular point, the function need to be defined. So therefore we are basically talking about the common domain. Now we have two functions, so the two functions must have a common domain in order to this particular properties to be holding true, right? Please let me know this is clear or not. Is this part clear? Alright, so therefore this f and g are two real functions with a common domain d, right? And then if you try to find out the limit of the summation of the function, it is simply equal to the limit of the f of x plus limit on the g of x. And similarly for subtraction also, you just have to subtract the individual limits. Now, if you multiply any constant with the value of the function, then the constant will simply be multiplied as a constant to the limiting value of that particular function. Similarly, if we need to multiply two functions and take the limit, it is equally true to calculate the limits of the individual function and then multiply it. Similarly, for division, again this particular holds true, but in this case you have to be very cautious that the limit x tending to a of g of x should not be equal to 0. Otherwise, this particular division is not possible. Okay, I hope this part is clear. Now next moving forward, so if you need to find out the limit of f of x to the power n, it is equally true that to calculate the limiting value and then raise to the power n. Similarly, whenever you have limit of any function raised to the power another function, it is equally true to calculate the limit of that particular function raised to the power limit of that particular function and then evaluate the answer. Alright, and similarly the last property says that if f of x, so this is basically trying to write it as, so if f of x is less than or equal to g of x, then at a particular point x equal to a, if I try to take the limit, then this particular property will also hold true. And in this case, I will try to extrapolate this particular property to one of the very important property that is called as a sandwich theorem. Okay, so what is a sandwich theorem? Saying that, so the sandwich theorem is basically talking about that now many cases it might be possible that we are not able to calculate the appropriate value of the function. Okay, that we are not able to calculate the formula or the equation for the given function, right? It might be possible that the function is very arbitrary or non-linear kind of function. Okay, so we are not able to get an exact mathematical equation representing to it, right? For example, if I have a graph something like this, very arbitrary in nature, right? Something like this, right? But what does the sandwich theorem talks about? So let us say this particular point is basically x equal to a. Now sandwich theorem says that now if this is an arbitrary function, let us call this arbitrary function as some g of x. So at this particular point x is equal to a, if this function is bounded by, if this particular function is bounded by two function, let us call this first function as h of x, which is the upper bound, and the lower bound of the function is given as a of x. Okay, so at that particular point x equal to a, this particular g of x function is bounded by the maximum at h of x, which is a defined function, and we know the mathematical formula relating to it. And similarly the minimum value, it is also the lower limit is defined by the another function f of x, for which again we know the proper expression regarding it, right? Now the sandwich theorem says that if f of x is less than g of x is less than h of x at x equals to a, okay, and the limiting value at x equals to a for the lower limit, that is f of x, and for the upper limit h of x, if they are equal, if these particular two criteria are satisfied, then by sandwich theorem we can simply say that the limiting value for x tending towards a for this very arbitrary function g of x is simply equal to this particular value of limit. So let us call this limiting value of a of x and h of x are equal to some L. So then the limiting value of g of x at that particular point x equal to a is also equal to L. So that is what the statement of Sandwich theorem is. Okay, I hope this is clear. Okay, so this is the statement of Sandwich theorem. Is this clear to all of you? Please let me know this particular part is clear or not. Okay, I'm expecting this part is clear. Okay, fine, fine. Please let me know if you have any questions. Okay, and if you're watching this session after the live session is over, then don't forget to, even if you have any concept, any difficulty or any doubt, please don't be ashamed of asking. Okay, you can always put your doubts in the comment section. Okay, I'll be very happy to answer all of your questions. Okay, and what also you can do is that you can try to join the Telegram channel from the link in the description. Okay, if you join the Telegram channel, the advantage is that you will get access to all the lecture materials as well as mock tests and very many of the short notes, okay, which I keep on updating on the regular basis. Okay, so please make sure that you join the Telegram channel. All right, so, and if you, even if you have any questions, you can always ask that question in the Telegram channel itself. All right, so I'm expecting this part is clear. Let's move forward. Let's move forward with this particular part. If this part is clear, let's move forward. Okay, so the next property is saying that now we are having some of the important formulas that you need to understand, before we start to solve the question. So the very first formula is that, the very first formula over here is that limit x tending towards a x to the power n minus a to the power n divided by x minus a is given as n into a to the power n minus 1, is given as n into a to the power n minus 1. Similarly, if we have the division of x to the power m minus a to the power m divided by x to the power n minus a to the power n, the value is going to be m by n into a to the power m minus n. This is simply by doing this particular analysis over here, right? And some of the important trigonometric limit is that limiting value of sin x by x is equal to 1. Similarly, limit x tending towards 0, tan x by x is also equal to 1. And one of the very important limit is that limit x tending towards 0, 1 minus cos x divided by x squared is equals to minus of 1 upon 2, is equals to minus of 1 upon 2. All right, so I hope this is clear. Okay, so I hope this part is clear to all of you. Please let me know if this part is clear or not. Okay, so I'm expecting this part is clear to all of you, and please make sure that you recall these parts before we start to solve the questions. Okay, and then let's move to the exponential limit. So the exponential limit, that is limit x tend to 0, e to the power x minus 1 by x is equal to 1. Similarly, if you calculate the limit x to the power 0, x to the tending to 0, a to the power x minus 1 by x, the value is equal to natural log of a. Okay, similarly, now this is called 1 to the power infinity form. Okay, this is called as a this is called as a 1 to the power infinity form. Okay, so whenever you have to evaluate the limit for 1 to the power infinity form, the formula is as follows. So okay, I hope you recall this particular formula. So this is going to be really important before we start to solve the real questions. So by now, what do you understand by the part of limit is that limit is nothing but it is a value of the function where we are not able to exactly put the value of x. Okay, it is just the value of the function at that particular point. Instead of talking about the at a defined point or at a particular point x, we are trying to look at the value of the function at the neighborhood of x. Okay, so when we try to say that the limit x tend to 0, so we are especially looking out for the value of the function in the neighborhood of x equals to 0. Okay, I hope this is clear and simple. Okay, this is very important to understand the concept before we actually start to solve the questions. Okay, that's why I'm spending much time over here. All right, so let's proceed further. Then I have some of the important expansion that you need to recall before you start to solve the actual paper. All right, because if you look at the questions, many times the use of expansion is going to be very simple, and by using expansion we are going to get our answers very quickly. Now let me tell you that these all expansions come from one of the very important result that is called the Taylor series expansion. Okay, so using the Taylor series expansion, these all results are derived. Okay, using the Taylor series expansion, these all results are derived. Okay. Alright, so what is the Taylor series expansion? So Taylor series expansion talks about for a continuous and differential function, okay, that if I need to find out the value of the function at some neighborhood of x, if I need to find out the value of the function, or let us say that if I need to find out the value of the function at some neighborhood of a, okay, now I know what is the behavior of the function at x equals to a. I know what is the behavior of the function at x equals to a. Now I want to predict what is the value of the function at x equals to at value when I'm putting f of x plus a. So I know what is f of a. I want to know what is the value of f of x plus a. So what Taylor did is that, so what basically is done that now if you don't know what is the nature of the function, is it increasing, is it decreasing, now simply what you can do, and if you don't know anything, what basically initially try was that let us consider this sum as linearly increasing or either linearly decreasing way, right? So in that case, what you do, you try to find out what is the slope at this x equal to a point. Okay, you try to find out the slope at x equal to a point and try to extrapolate this line and then get this value of this x equal to a x plus a. Okay, then f of x plus a, that's the value we are trying to get it, right? But what Taylor did is that in general he tried to expand and tried to fit a polynomial in between these 2 points, okay, such that this particular function will always holds true even if it is an increasing function or a decreasing function. So the result for the Taylor series expansion, so the result for the Taylor series expansion is simply written as f of x plus a. So I know what is the value of f of a, so that f of a plus now x is basically the value by which this a and x plus a is deferred. Okay, so this is basically, so in the number line when I say that a and x plus a, this particular quantity was basically equals to x, right? So this then, so the value is basically f of a plus x times of f dash of a, or the first derivative of x at a, plus x square by 2 factorial into second derivative at x equals to a, plus x cube by 3 factorial into third derivative of x at a, and so on up to infinite numbers, right? So this is called as a Taylor series expansion, and we are generally going to use this particular expansion to get to the results of what is basically mentioned in the series. Okay, so if you just take, in this case, if you take f of x as e to the power x, and if you just try to simplify this result, you are going to get the same result. So what I'm going to do, so instead here this a is basically equal to 0, here a is basically equal to 0, so e to the power x is basically equal to f of 0 plus x into f dash of 0 plus x square by 2 factorial into f double dash of 0, and so on. So if you just look at this expression, it is going to be 1 plus x, and e to the power, a derivative of e to the power x is basically e to the power x, and putting a 0, it is going to be 1 plus x square by 2 factorial, and so on up to infinity, okay. So this is going to be the results over here. So that's how the results are derived. Okay, so that's how all the expressions are derived. Okay, so please make sure that you recall these derivations, or not the derivation is important, but you have to remember this particular expansion. Okay, because especially for solving difficult questions of advanced, these expansions are going to be very, very important and useful. Okay, and these derivations are such that these are not difficult to understand, remember. Once you start solving question by using these derivations or by using this particular expansion, you are going to recall it as it is. Okay, so I don't think that there will be much of a pain to recall or to remember this particular concept. Okay, so with this part, so let me know that this part is clear to all of you or not. Please let me know this part is clear to all of you or not. Okay, I'm assuming this part is clear to all of you. Okay, all right, so let's move forward. Now one of the very important rule to get the limit value or the limiting value quickly is called as the L'Hopital rule. Okay, so someone pronounces it L hospital, but that's L'Hopital. Okay, so what is it saying, that if I have two functions f and g which are differentiable such that the limiting value of these two functions are either equal to 0 or either equal to plus or minus infinity. That means if I have the fraction of f of x and g of x, they are either of the form 0 by 0. So either the limit of the form 0 by 0 or the limit of the form infinity upon infinity, then we are going to use this particular result of L'Hopital rule or L hospital rule. All right. So what is the result saying that? Therefore, the limit of f of x by g of x is simply equal to limiting value of f dash of x by g dash of x until and unless we are getting a finite value. So if we are getting a finite value, we'll stop. Otherwise, we'll keep on differentiating unless we get a finite value by putting x equal to c. I hope this is clear to all of you, right? So these are all the important topics that you need to recollect before we start to solve the actual questions. Okay, so with this part, I hope this is clear to all of you. So with this part, let's get started on solving the problems. Okay, so the very first problem is on your screen over here. All right, so the question is talking about that we have a function. Now before we start to solve the question, I would request all of you to please have a look at this question and try to solve it by yourself. Okay, because if you're able to get the answer correctly before me, you are going to have that particular confidence. Okay, and that particular confidence will be very, very important in order to solve any questions of mains and advanced in the future. All right, so let's see how we are going to solve this question. So it is said that we have a function which is defined as x square minus 1 into x square minus of a plus of 2 mod of it plus of mod cos of mod of x, right? Now this is not going to make any difference because ultimately cos is a even function, right? So and so whatever your, but this is basically going to tell you that whatever input you are giving in x, it is just taking the positive input, right? So it is saying that it is not differentiable at 2 point x equals to alpha equal to 2 and x equal to beta. So there it is not differentiable. Okay, it is not differentiable seeable at x equals to alpha and beta, and the value of alpha is equals to, and the value of alpha is basically given. What is the question talking about is that, and the question is talking about that we have to find the distance of the point alpha comma beta. We have to find the distance of the point alpha comma beta from the equation of the line which is given over here, right? So we have to basically calculate the value of beta, right? So let us see how we try to solve for it. Now whenever any mod of any expression is given in a particular problem, we know that modulus of x is not differentiable at x equals to 0. So modulus of x is not differentiable at x equal to 0. So whenever mod of any f of x is given, we have to check at those points where f of x is equal to 0. So similarly, for this particular expression over here, we are going to check for the values of x when this particular value is equals to 0. So the x we are getting from here are those x where this particular modulus of x square minus a square plus 2 is not differentiable. So from here, one of the root is given as alpha and other root is given as beta, right? So alpha is basically given as 2 and beta is basically given, not given, right? So we know that if this is the two roots of this equation, so a product of the roots are going to be simply equal to 2, right? So from here your beta is going to be equal to 1. So from here your beta is going to be equal to 1. Now if you put x equals to 1, so if you put x equals to 1 over here, it is basically talking about that the function is not differentiable. Okay, but unfortunately x equal, so this is basically corresponding to x equal to 1, right? It is basically corresponding to x equal to 1. Now unfortunately if you see that x equal to 1, this particular function, that is x square minus a, is going to be equal to 0, is going to be equal to simply equal to 0, right? So whenever this particular part is not existing, right? So if you put x equals to 1, this particular part is not existing, right? So therefore x equal to 1, the function is differentiable, right? So therefore this is not going to be the point where the function is not differentiable. Rather this cos of mod of x is not going to be differentiable at x equal to 0, right? So therefore your beta should be equal to 0. The beta should be equal to 0, and therefore you have to basically find the distance of the point. You have to basically find the distance of the point 0, 2 from the line 12x plus 5y plus 10 is equal to 0. From the line 12x plus 5y plus 10 is equal to 0. And from here, you'll get the distance simply as by putting the distance formula. Okay. So this is going to be the answer as, so this is going to be 34 34 upon 13. Okay, so 34 upon 13 is going to be the correct answer. I hope um, so please let me know if this is correct or not. Actually, the thing is that actually the question, the answer key was given as the answers were not mentioning. Okay, and this question actually dropped up. Okay, because the answer should be equal to 34 upon 13. But what the examiner, while he was making the question, he or she, I don't know, while he was making or she was making the question, he considered this particular point x equal to 1 as the point where it is not differentiable. So he put this to 1 over here, and then if you put it over here, it is going to be plus of 5, so that is going to be 39, and that's how you got the answer as 3, right? So that is a wrong answer. Okay, so make sure that you don't understand that particular thing. Okay, so the correct answer is basically 34 upon 13. Okay, which is not matching, and that's how this question was actually dropped out. Okay, but this question was kind of interesting to understand that whenever we have a differential function, the differential function, or in terms of mod of a function, is given, that particular function is not differentiable at this point where the part of the function inside the modulus is equals to 0. Okay, so you have to understand that at x equal to 1, this beta equal to 1, this particular point is differentiable. So this x equal to 1 is not a point where it's non-differentiable. Okay, so make sure that I try to understand this particular part. All right, so with this you will have the answer as 34 upon 13. All right, so let's move further. Let's move forward. Right, the next question we have with us is a very interesting problem. Now I would request all of you to please try to solve this particular problem. Please try to solve this particular problem. Please try to solve this particular problem. All right, so try to look into this problem. All right, so I hope you actually try to solve this problem. So the problem is very simple. What you need to do, you have to try to get this. Now, especially if you are looking at this problem and thinking that it's a problem of a limit, I would say it's not actually a problem of limit. It is a problem of sequence and series. Okay, so let us try to see how we try to decompose this problem. Okay, so the problem is given as, so if we look at the summation which is given over here, the summation is given as k is equal to 1 to n k cube plus 6k square plus 11k plus 5 whole divided by k plus 3 factorial. That is what is given, right? So what I am going to do is, over here it can be written as summation k is equal to 1 summation k is equal to 1 to n summation k is equal to 1 to n. Now if I look at this particular expression, I will try to factorize this particular expression, and this expression is very simple expression, and it is the factorization of k plus 1 into k plus 2 into k plus 3 minus of 1, right? So this is basically so if we have 6 over here, it should be like this, but that's why we are basically writing it minus of 1. Okay, so why I did factorize this part out, you will try to understand very soon. So and whole divided by k plus 3 factorial, right? Now I am trying to write this particular expression as summation of k belongs to 1 to n. Now this k plus 1, k plus 2 and k plus 3, and if you divide it by the k plus 3 factorial, then it is going to simply equal to 1 upon k factorial. It is simply going to be equal to 1 upon k factorial, because I can write n factorial as n into n minus 1 factorial. Very simple, right? So this is going to be equal to 1 upon k factorial minus 1 upon k plus 3 factorial minus 1 upon k plus 3 factorial. All right, this is the simplified expression of this particular summation. Okay, so the thing is very simple. Once you're able to decompose this particular part into this way, then the question is very simple and very easy, right? So this is the step that you need to understand, and whenever this big kind of expression are given, it is always advisable to try to factorize this expression and try to cancel out with the terms and try to get in terms of the telescopic sequence, that is one term minus another term, right? So once you put the values of k is equal to 1 to n, that terms are going to be cancelling out that kind of terms, right? So especially over here, now if I take the limit n tending towards infinity on this particular term, on this particular term. So what you're going to see that if I put k is equal to 1, it is going to be 1 upon 1 factorial minus 1 upon 4 factorial plus 1 upon 2 factorial minus 1 upon 5 factorial plus 1 upon 3 factorial minus 1 upon 6 factorial and so on, right? So I'm taking that in the next page. So it is going to be 1 upon 1 factorial minus 1 upon 2 factorial plus 1 upon, sorry, 1 upon not 2 factorial. It is basically 1 upon 4 factorial, right? And then 1 upon 2 factorial minus 1 upon 5 factorial plus 1 upon 3 factorial minus 1 upon 6 factorial plus 1 upon 4 factorial minus 1 upon 7 factorial and so on, right? So let me write few more terms to explain you these things, right? Now interestingly, what you will observe that this 1 upon 4 factorial and this 1 upon 4 factorial get cancelled out. Similarly, this 1 upon 5 factorial will also get cancelled out, with this 1 upon 5 factorial, right? So if you look at this particular expression, so and that's how the fashion of the terms are getting cancelled out. So it is kind of a telescoping series, and if you go up to infinity, the terms are going to be very terms, and that is going to tend towards 0, because 1 upon infinity is going to be 0. So we are not taking it, and because the question is mentioning out the limit and tending towards infinity, right? So therefore the ultimate terms is going to be the first initial few constant terms which are not getting cancelled out, that is 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial. Those are the only terms in this particular expression. Okay, so with this, the answer you will be having it as 1 plus 1 by 2 plus 1 by 6, and that is going to, if you evaluate this is going to come out as 5 upon 3. So from here you will get the answer to this particular problem as option number A. I hope this part is clear to all of you, right? So from this you will have the answer to this particular problem as option number A. I hope this is clear to all of you. Please let me know if this particular part is clear or not. Okay, I am assuming that this particular part is clear to all of you, right? It's very simple. You just need to try to use your own merit to understand that how we try to decompose this particular problem in a telescopic series, right? And then once you get the telescopic series, the problem is very simple. Okay, please let me know if you have any questions. So I'm going through a live chats. Please let me know if you have any questions. Okay. So I'm assuming that you don't have any questions. Please don't be afraid to ask any question. Okay. So please ask if you have any questions. Okay, so I'm expecting this question is clear to all of you. So let's proceed with the next problem. Right? So the next problem is on your screen. Please try to solve this particular problem. Okay. Please try to solve this particular problem. This problem is again very interesting problem. Okay. So let us see how we approach to solve this particular problem, right? So it is saying that this bracket or the square bracket of x denotes the greatest integer function. Now we all know this particular concept that this square bracket is denoting the greatest integer function. And it is said that let m and n be the number of points, where this particular function is not continuous and not differentiable. So we have to look for those points where it is not continuous and not differentiable. And once we are able to do that, we have to count the number of points, that is m plus n. Okay. So if you look at the given function over here, we have the function given as greatest integer of x plus mod of x minus 2. plus mod of x minus 2, right? Now the domain of this particular function is given as it is between minus 2 to 3. It is between minus 2 to 3. Now you know that these particular functions are all piecewise defined functions. These particular functions are all piecewise defined functions. So we are going to simply use that particular concept that within this particular interval of x, we will have a particular value, right? So let us try to expand these relations between each of the particular intervals of x. Okay, so if we look at the interval of x starting from minus 2 to minus 1, right, this greatest integer of x is going to be minus of 2, and this is going to be equals to, this is going to open up in negative, right? So that is going to be 2 minus x. So therefore you will have this value of the function that is minus of x. Similarly, when x is basically between minus 1 and 0, this greatest integer is going to be equal to minus 1, and this is going to open up again in negative. It is going to 2 minus of x, and therefore ultimately you will have this particular function value at x plus 1. Similarly, when your x is basically between 1 and 0, this greatest integer is going to be 0, and this is going to be 2 minus fx. Similarly, moving further, when x is basically between 1 and 2, it is going to be equals to minus of x plus of 3, and when x is basically between 3 and 2, it is going to be equal to x, right? So I hope this is clear. Okay, so if you look at over here, let us try to count the number of points where it is not continuous, or what you can do, you can try to plot them on the graph sheet. Okay, you can try to plot them in the graph for this particular interval, what type of graph you are getting. Based on that also, you can also try to answer this question of the points where it is not continuous or not differentiable. Is this part clear? So if you look into this particular problem over here, now let us try to look at the continuity at the endpoints. So at x equal to minus of 1, this particular value is going to be 1, and this particular value is going to be 0. So therefore minus 1 is a point of discontinuity. Okay, so I'm writing discontinuity point. Okay, so x is equal to minus 1 is a point of discontinuity. Similarly, at x equals to 0, it is again a point of discontinuity, right? Similarly, at x equals to 1, it is again going to be the point of discontinuity, right? And similarly, at x equals to 2, it is again going to be the point of discontinuity. So therefore, there are 4 points where this particular function is not continuous, right? So m is going to be equal to 4. And m is going to be equal to 4. And if you look at the derivative, so then what I'm going to do is that I'm going to check the continuity of f dash of x. So if I try to find out the f dash of x, this particular value, the first value is going to be minus of 1 when x is basically lying between minus 2 to minus of 1. Okay, and when x is lying between 0 and minus of 1, it is going to be equal to again minus of 1. Similarly, when x is lying between 0 and 1, it is again going to be minus of 1, and when x is lying between 1 to 2, it is again going to be minus of 1, and it is going to be 1 when x is lying between 3 and 2, right? Is this part clear? Okay, so once we have these parts, then you can see that at x equals to 2, this particular f dash of x is not continuous. Hence, x equal to 2 is one of the point of discontinuity. One of the point of non-differentiability, right? It is not differentiable at x equals to 2, which is very obvious, very obvious from looking at this particular mod of x minus 2 over here, right? So mod of x minus 2 is definitely going to be the point of not differentiability, right? But the thing is that whenever you look at this particular function, greatest integer function, it is not continuous and not differentiable. So whenever a particular function is not continuous, so the thing is that for a differentiability to exist, the particular condition of continuity must hold true. So if the function is not continuous at those 4 points, then it is definitely not differentiable at those particular 4 points, right? So then why do we need to check for the differentiability case? We don't need to perform this particular analysis. Over here. We don't need to do this particular analysis because we know that if a function is not continuous, it is not differentiable. So then the question of differentiability does not hold true. So therefore, the number of points where this particular function is not differentiable is again going to be equal to 4. So that's how we will have m plus n is going to be equal to option 8, which is option number C in this particular problem. I hope this part is clear. I hope this particular part is clear to all of you. Is this part clear to all of you? Please let me know. Please let me know this part is clear or not. Okay. So please let me know if this particular part is clear or not. Okay. If something is not clear, please ask me. Okay. So please ask the question in the live chat. If some of the parts is not clear, please ask that question in the live chat. Alright. So I'm looking for your live chats. Please let me know if you have any questions. Please let me know if you have any questions. Don't worry, I'm going to take up all the important questions. Okay. So now these kinds of problems are very, very crucial if you look into the JEE mains exam pattern. Okay. Because especially in JEE mains, the piecewise defined functions are very, very important. Okay. So let me write this over here. So for JEE mains, so especially if you look at JEE mains, these important piecewise defined functions are very, very important. Okay. For the case of limits, piecewise defined functions are very important. Okay. These piecewise defined functions are very important for JEE mains. Okay. Because for piecewise defined function, the concept that you are going to use is that you will have to calculate the left hand limit and you have to calculate the right hand limit and then check for the equality. So if this equality holds true, then the limit value or the limiting value of the function will exist. Otherwise, the limiting value of the function won't even exist. Okay. So that is very, very important to understand before we start to solve any questions of the type of piecewise defined function. Okay. What do I mean by piecewise defined function is that piecewise defined function are a function which will have one particular value of y for a particular interval of x and will have different definition or will have different values of y for different intervals of x. Okay. So for example, if I take a function f of x, it is defined such that it is equal to phi of x when x is greater than or equal to a, and it is equal to psi of x when x is less than a. Okay, so this kind of function which has multiple definition depending on the interval of x, this kind of function is known as piecewise defined function. Okay, so for piecewise defined function, you know that the continuity nature, you must be trying to check it at exactly at that particular point where the function is changing its definition. Now I will take some question to explain you this particular part, but it is very, very important to know that for piecewise defined function, you have to, the point of interest should be at the point where the function is changing its definition, because that is the point which is very much likely to be not to have the limit value not existing. Okay, or the limit to be not be existing. All right. Is this clear to all of you? Is this part clear to all of you? Please let me know. I hope this particular part is clear to all of you, right? So even if you have any question, please don't hesitate. Okay, please don't hesitate to ask me the question. So with this, I hope this particular part is clear. Okay, I hope this particular discussion was fruitful enough and you also got the discussion. Okay, if you have any question, please let me know in the live chat. Okay, and if you are new to this particular channel, I would request you to please subscribe to the particular channel, because this channel, through this particular channel, we are basically trying to reach out all the students who are actually preparing for JEE mains, and so that I and my team can help up those students who are basically needing those particular kind of lectures, right? These sessions are basically free of cost on the YouTube, right? So you don't have to pay any penny to watch this session. Okay, so please let me know, please help me spread these particular lectures to all of the needy people. Okay, because not all students can actually afford to get the hefty fees of the coaching classes, and that's how they don't miss out the opportunity. So we are basically live on this particular channel, we are discussing in order to help out all the important those needy students who want to prepare but they don't have the resources. So through this channel we are trying as a medium to help cover that barrier. Okay, I hope you will help me spread this particular channel to all of those needy students. Okay, so don't forget to share these videos among your friends. Okay, So if you are watching this session and you like this particular session, don't forget to share the session along with your friends. Okay, because if you bring your friends along the session, what thing you can benefit is that your friends will also be trying to solve this question, you will be also trying to solve this question, and both of you will be trying to achieve the answer. The one who got the answer more quickly or more correctly will be the winner, right? So you can have a competition along with a friend, which is a healthy competition, right? I know that I appreciate having healthy competition, not a toxic competition, right? So that is kind of a healthy competition because you will get to learn. So if your friend is better than something at some part than you, then you will try to learn from your friend, right? Similarly, your friend can also do the same thing, right? So if you are better at something, maybe your friend can also learn from you. Okay, so that's how the world actually works, right? So you should try to look into that particular thing, right? So that is kind of a healthy competition that you always should try to approach. Okay, I hope this is clear. I hope this particular discussion was clear. Okay, so let's move to the next problem. And the next problem is again a very interesting problem on the topic of limits, right? So if you look at this particular problem over here, we have to do a lot of rationalization. We have to do a lot of rationalization over here. So first of all, let me try to simplify this particular expression. So it is said that limit x tending towards 0, I have cosec x, then I have, and if I multiply with square root of this part plus square root of this part, then I'm going to get it as a square minus of b square, which is simply going to be equal to cos square x, or cos square x plus 3 times of cos x minus sin x minus of 4. Because I'm doing it, I'm basically trying to do this a square root of a plus b into square root of a minus square root of b. It is simply equal to a minus b, right? That's what I'm going to do over here. So and then divided by square root of this particular term, which is 2 times of cos square x plus 3 times of cos x plus square root of cos square x plus sin x plus of 4, right? Now this cosec x is basically 1 upon sin x. This cosec x is basically 1 upon sin x, right? Now I have told you that trigonometric limits that sin x by x is equals to 0 for x tending towards, is equals to 1 for x tending towards 0, right? So we are trying to get this particular kind of quantity from here. So if I try to simplify it further, so this is going to be limit x tending towards 0, 1 upon sin x, and then let me take the cos term together. That is going to be cos square x plus 3 cos x minus of 4, that's the quadratic in cos x minus sin x, whole divided by square root of that particular term plus square root of that particular term. Okay, now interestingly, you can factorize this part out as, so this particular part will become 1 upon sin x whole multiplied with, now you can factor this part out as cos x plus of 4 into cos x minus of 4 minus of 1 minus sin x whole divided by that particular expression, Now we are going to simply use some of the important trigonometric formulas. So cos x minus 1 is simply equal to, so this is going to be simply equal to 2 times of sin square x by 2. So we are basically going to use the half angle formulas over here. And similarly, I can write sin x as 2 times of sin x by 2 into cos of x by 2, right? So that if I try to do that, then the numerator will become 2 times of sin square x by 2 multiplied with cos of x plus 4 minus 2 times of sin x by 2 into cos of x by 2, right? And whole divided by, now similarly this denominator sin x I am also writing it as sin of x by 2 and cos of x by 2 into that particular quantity, that bigger expression, right? Now the advantage of doing this, that this sin x by 2, one of the sin x by 2 and this will get cancelled out. Okay, and this 2 is also getting cancelled out. So ultimately you are getting the result as minus of sin x by 2 into cos of x plus 4 minus cos of x plus 4 whole divided by cos of x by 2 into that particular bigger expression, Now if you put that limiting value, that is x tending towards 0, so if I put x equal to 0, in this case this value is going to be a finite value. It is not going to be of the indeterminate form of either of 0 by 0 or infinity by infinity. It is not going to be like that. So therefore, if you put the value, you are going to get the answer simply going to be equal to minus 1 upon 2 root 5, minus 1 upon 2 root 5. That is going to be the correct answer for this particular problem. So from here, you can see option number D is going to be the correct answer for this particular problem. I hope this particular problem is clear, right? So it was more of like simplifying the question in terms of rationalizing it, right? So if you look at this particular expression by putting x equal to 0, it is basically the form infinity into 0, right? So you just have to convert this particular infinity into 1 upon 0. So that is going to be 0 by 0 form. And once you get 0 by 0 form, what the basics is saying that you can try to rationalize this particular expression and try to find the limiting value. So from that also you can try to approach the solution over here. I hope this particular part is clear to all of you. I hope this particular part is clear to all of you. Right. Please let me know if this particular part is clear or not. Please let me know if this particular part is clear or not. Okay. This part is very, very simple. So just you have to find out that the limiting is basically the form 0 by 0. So once you understand that, then you have to try to do the simplification by rationalization. And once you do the simplification, you are going to get the answer very straightforward, right? So once you cancel out those particular terms because of which you are getting 0 in the numerator and 0 in the denominator, if you try to cancel the common factor, you are going to get a term which is basically going to give you the finite value or finite answer. Is this clear? Is this clear to all of you? Is this part clear to all of you? All right. So I'm assuming this particular part is clear. Let's proceed with the next problem. So if this part is clear, let's proceed with the next problem. So next problem is again very, very interesting problem, which is given in terms of a functional equation, Okay. Please try to go through this particular problem. Now I will tell you that how will you solve the functional equation questions when they are of this particular following type. Okay. Now there is one of the interesting property that will actually help you out to solve this particular problem over here. So that I am going to discuss in this particular problem solution. Meanwhile, please try to solve it and check what the value are you getting. What is the value are you getting? Okay. Try to solve it by yourself. And see what the value are you getting. Try to solve this particular problem and tell me what is the value you are getting. Please try to solve this particular problem and tell me what is the value you are getting. Okay. So if you look at this particular value over here, it is said that the function is defined for all real number except x equals to 0. The function is defined for all real number except x is equal to 0, and the codomain is all real number. And the function is defined with the given functional equation of the form f of x minus 6 times of f of 1 upon x is equals to 35 by 3x minus of 5 by 2. 35 by 3x minus of 5 by 2. That is how the functional equation is given over here. Now, if you look at this particular functional expression over here, how to solve this or get a meaningful data out of this particular functional expression. So the best way, what you can try to do it over here is that, now since you look at this particular problem, that is one you are putting as x and one you are putting it as 1 upon x. So what is the best thing is that, what you can try to do it over here is that, if you try to replace this x with 1 upon x, the meaningful data you are going to get it over here is that, so therefore your value will become something like, so if you just replace this x with 1 upon x, this value is going to be f of 1 upon x minus 6 times of f of x is going to be equal to 35 by 3 into x minus of 5 by 2. Now interestingly, what you are going to see over here, now if you just try to evaluate f of x from here, what I would suggest is that you can try to cancel out this f of 1 upon x. So if you just try to simplify this part over here, so this is, let us call this expression number 1 and this is called as equation number 2. Okay. So from this equation 1 and 2, let me do one thing, that so let me get this value of f of 1 upon x f of 1 upon x is basically equals to f of x minus 35 upon 3x plus of 5 by 2 whole into 1 upon 6, right? So let us try to put this value into this particular second expression and let us find out what is the value of f of x we are getting. So if you just do that simplification, you will get simply that f of x is equals to minus of 2x minus of 1 upon 3x plus 1 upon 2 plus 1 upon 2. So that is the simplified expression that you will be getting as f of x. So the advantage of simplifying this functional equation by putting x as 1 upon x, the advantage you got it over here is that you are able to easily simplify this part and get to the value of the function, get to the functional definition. Is this part clear? You got to the functional definition from here. I hope this part is clear and making sense to all of you. I hope this part is clear and making sense. Please let me know if this part is clear or not. Please let me know if this particular part is clear or not. Okay, now from here, once you're able to calculate this particular functional value, then if you look over here, your beta is basically the limit x tending towards 0, 1 upon alpha x plus the function value of x, right? So how do we solve for this? So we have to basically find out the limit x tending towards 0, 1 upon alpha times of x minus of 2x minus of 1 upon 3x plus of 1 upon 2 right? So from this we have to evaluate the limiting value so as to get to the value of beta. Now interestingly, at x equal to 0, this particular function will be kind of a non-defined. Similarly, this is going to be also non-defined case, right? But interestingly, if I put the value of alpha is equal to 3, then this particular part is going to cancel out this particular part, and similarly the value of the limit, that is beta, is going to be simply equal to 1 by 2. You can also try to get this expression by doing this. So it is going to be alpha x multiplied with 3x, right? So multiply 3x, and then this is going to be equal to 3x minus of 2x into 3 alpha x square minus alpha x plus of alpha 3 alpha x square, right? So from here also we can check out the solution, right? If you try to do by the L'Hospital rule, you will see that the alpha value should be equal to 3. Okay, it should come out to be 3, otherwise the limit won't be a finite limit. So therefore, for getting a finite limit, your alpha should be equal to 3, and if alpha is equal to 3, then the value of the limit is going to be simply 1 upon 2. It's going to be simply 1 upon 2. So from here the value of the expression alpha plus 2 beta is going to be equal to 4. That is option number D, which is going to be the correct answer for this particular problem. Please let me know this particular part is clear or not. I hope this particular part is making sense to all of you, right? I hope this particular part is making sense to all of you. Please let me know if this particular part is making sense. Okay. So I am assuming that this is clear to all of you. So let's try to look into the next problem over here, right? So again, the next problem, if you try to look into over here, is again a very, very interesting problem. Okay. So if you try to check out the form of the limit over here, you will find that the limiting form is basically of the type 1 to the power infinity. Right? So if you just try to look at the problem directly, you're not going to get it as 1 to the power infinity form. Rather, by some simplification, you're going to get it of the form of 1 to the power infinity. So I'm requesting all of you to please try to solve this problem. I hope you know how to solve the question of 1 to the power infinity. So let us recall that if the function f of x at some value x equal to a, if this value is equal to 0, and the limiting value at x equal to a, if the value of the function g of x is equal to infinity. Now the concept of infinity or the function limiting value to be infinity is not a correct concept. So rather we should try to talk about that. Let us say again it is g of x is also equal to 0. Then if I have to find out the limit for 1 plus f of x whole to the power 1 upon g of x for the limit x tending towards a, then this is going to be the form of the limit 1 to the power infinity limit, right? This is of the form 1 to the power infinity. This is simply going to be the form of 1 to the power infinity. And whenever the limits are of the form of 1 to the power infinity, similarly, when the limits are basically the form of 1 to the power infinity, the value is equals to e raised to the power limit x tending towards a f of x into 1 upon g of x. So what I'm doing, I'm getting this particular function minus of 1 into into the g of x as it is, right? 1 upon g of x as it is, and that's how we get to the value of this particular limit. This type of limit is called as a 1 to the power infinity form, and which is one of the indeterminate form which we try to calculate the limit for, right? So I hope this particular part is clear. I hope this particular part is clear to all of you and is making sense. Okay, so if you just look at this problem, so what I would suggest is that try to divide it by x square. So if you try to divide it by the x square for the first term, it is going to be 2 minus 3 by x plus 5 by x square. And similarly over here, if you do the same expression, it is going to be 1 minus 1 upon 3x. And in this case, I am taking 1 upon 3x as common, whole to the power x by 2 divided by, and in this case again we are taking x square common, so it is going to be 3 plus 5 upon x plus 4 upon x square, and here we are having 1 plus 2 upon 3x, 1 plus 2 upon 3x whole to the power x by 2, I hope this part is clear. I hope this particular part is clear, right? So now if you look at this expression over here, it is basically the form of 1, this particular form of the limit is basically the form of 1 to the power infinity, right? And this is going to be the form, and this particular limit is going to simplify out as, because any constant divided by infinite or very large number is going to be tending towards 0. So this form is going to be 0, right? So therefore the first part is going to give you the product as, this particular part you are going to get it as 2 upon 3. And similarly for this part, the result is going to be equal to e to the power limit x tending towards infinity minus of 1 upon 3x into x by 2, which is also going to give you the result as e to the power minus of 1 upon 6. And similarly the denominator is going to be e to the power limit x tending towards infinity 2 upon 3x into x upon 2, so which is going to be 1 upon 3. So simple, from here the value of the limit you are going to get it as 2 upon 3 into e to the power minus of 1 by 6 divided by e to the power 1 by 3, which is going to be equal to 2 upon 3 into e to the power minus of 1 by 6 minus of 1 by 3, which is going to be equal to 2 upon 3 into e to the power minus of it is going to be minus of 3 upon 6, okay, which is basically 2 upon 3 into e square, 2 by 3 e square, 2 by 3 e square. Oh, just let me see. Okay, sorry, very sorry, not e square, 1 by 2, right? So e root e. So from here you will get square root of e, right? So 2 by 3 square root e. So that is going to be the answer of this particular problem. So from here you can see that option number C is going to be the correct answer for this particular problem. Okay, option number C is going to be the correct answer for this particular problem. So I hope this particular discussion is clear to all of you. Is this part clear or not? Please let me know this particular part is clear or not. Is this part clear? Is this part clear to all of you? I'm assuming this question is very simple and straightforward, right? So for the one part, we are basically having infinity by infinity limit, and for the other part, we are having the 1 to the power infinity limit. Now, I just simply use the properties of the limits to calculate the individual property, and then we move forward, right? So you can try to recall the properties that I discussed in the beginning of this class, right? These are the properties, right? So I just applied the simple properties of the division and the product, right? So this must make sense to all of you, right? I hope this is clear, right? This part is clear. Okay. So switching gears, let's move to the next problem. Now I was discussing about the problems of piecewise defined, right? Piecewise defined. So this is a question which is piecewise defined. This is a question which is piecewise defined, and you have to basically try to solve this question by finding out the left hand and right hand limit separately, and then look for the value of the, because we have to discuss about the continuity also over here. So then you have to equate it to the value of the function at that particular point where you are trying to find out the continuity nature. All right. So please try to solve this question. Please try to solve this question. Please try to solve this problem. All right. So if you look at this particular problem, so if you try to solve this particular problem over here, this problem is very, very simple. Okay. So it is talking about the continuity nature. Okay. So you have to discuss about the the continuity at x equals to 0. Right. So the function is piecewise defined as f of x is basically, so for x less than 0, this particular definition of function is given, and for x greater than 0, again the definition of function is given, right? So let us try to find out the left hand limit of the function at x equal to 0. So at x equal to 0, first of all, let me find what is the LHL or the left hand limit, right? So therefore, limit x tending towards 0 minus, it is given as 2 by x into sine of k1 1 x plus sine of k2 minus 1 times of x, right? Now interestingly, this particular limit is very simple because we know that the limit x tending towards 0 is sine x upon x, is equals to 1. This sine x upon x is equal to 1. So therefore, we are going to simplify this part as 2 times of sine of k1 plus 1 times of x divided by k1 plus 1 times of x plus, and since we are dividing with k1 plus 1, so we have to multiply also with k1 plus 1, and plus sine of k2 minus 1 into x. So then we divided by k2 minus 1 into x, and since we are dividing it, so we have to multiply as well, right? So with this, you will see, or you will get the value of the limit over here will come out as 2 times of k1 plus 1 plus of k2 minus of 1, right? So from here, this minus will cancel out. So here you are going to get the value of k1 plus k2, 2 times of k1 plus k2 as the left hand limit of this particular function at x equal to 0, because we have to look for the continuity at x equals to 0, so I got a left hand limit as equals to 2 times of k1 plus k2, as 2 times of k1 plus k2. Now, so this particular k1 plus k2 should be, the left hand limit should be equal to the function of value at x equals 0, which is basically equal to 4. So from here, you get one equation in k1 plus k2, which is equal to 2. So let us call this as first equation. Similarly, we get one more equation from the right hand limit. So from the right hand limit, the limit is basically limit x tending towards 0 positive, 1 upon, 2 upon x natural log of 2 plus k1x divided by 2 plus k2x, right? 2 plus k2x, and that particular value should also be equal to 4, or the function value at x equal to 0. So what I can do over here is that I can try to write this part simply as, so this 2 I'm going to take it inside. So if you recall the property that is a times of log of some m, it is basically equal to log of m to the power a, right? So I'm just going to simply use this particular property in order to simplify this particular problem over here. So from this particular property, this value is going to be 1 upon x into log of Now if I take the square of it and I try to simplify in terms of fraction, it is going to be 1 plus k1 minus k2 into x whole divided by 2 plus k2 times of x, right? And then if you recall that the limit x tending towards 0, log of 1 plus x divided by x 1 plus x divided by x is equals to 1. Okay, so we are just going to use that particular property over here, that formula over here, and with this we are going to get the value of this limit as k1 minus k2 divided by 2, and that should be equal to 4. That should be equal to 4, right? That should be equal to simply equal to 4. Is this clear? Right. So from here you will get this k1 minus k2 is basically equal to okay, so I did one mistake. So I didn't try to square it. Okay, so actually I didn't try to square it. I cancel out this 2 with 4. Okay, so therefore this is going to be equal to 2. I'm extremely sorry, right? And this is very simple. This part I can simplify out, right? By in terms of 1 plus this particular expression, and from here I'll get k1 minus k2 as simply equal to 4, as k1 minus k2 is simply equal to 4, and this is my second equation, right? So on the first equation we have k1 plus k2 is equal to 2 and k1 minus k2 is equal to 4. So from here we have two equation, 2 unknowns. So k1 is equals to 3 and our k2 is equals to minus of 1 and our k2 is equals to minus of 1, right? So with these two values we are going to get the values of k1 and k2, and once we get the k1 and k2, k1 square plus k2 square, k1 square plus k2 square is simply going to be equal to 10. Is simply going to be equal to 10, which is option number B, which is going to be the correct answer for this particular problem. Which is going to be the correct answer for this particular problem. I hope this is clear. I hope this part is clear to all of you. Please let me know this part is clear or not. Is this part clear to all of you? Okay, I am assuming this particular part is very simple and clear to all of you, right? Okay. So I'm expecting this is clear. So once it's clear, we shall proceed with the next problem. Okay. Alright. So proceeding further, then this is going to be the last question for today's session. Okay. So let us try to see how we try to solve this particular problem over here. So this particular problem is again a very simple problem. Now for solving this problem, we have to use one of the simple expression, or you have to try to simplify this particular problem by knowing one of the important fractional expression, that is that this x plus 1 upon x can be written as 1 minus 1 upon 1 by x, 1 minus 1 upon 1 by x. So this part 1 upon e minus x by 1 upon x, 1 upon e by x plus x by 1 upon x is going to be equal to 1 upon e minus 1 upon x plus 1. Right. So from this part, it is going to be equal to 1 upon e minus of 1 plus 1 upon x plus 1 plus 1 upon x plus 1. Right. Now we have to just multiply this particular part with e into 1 minus e. Right. 1 minus e. So that is going to be giving you the result of the problem. Right. Now this particular part, we will have to write it as e into 1 minus e multiplied with this can be simply write it as 1 minus of e minus 1 divided by e plus 1 upon 1 upon x plus 1. Now the advantage of doing is that when you multiply with this particular part, it is going to simply equal to minus 1 plus. So it is going to be simply equal to this particular part, or if you try to replace that, it is going to be simply equal to plus of 1 minus of 1 by x over here, right? So this is the inside the bracket. So this is the expression which is inside the bracket, and then this particular whole raised to the power x, and then we have to calculate for limit x tending towards infinity. Now it is simply going to be the form of 1 to the power infinity, 1 to the power infinity. So therefore the result for this limit is e to the power limit x tending towards infinity x upon 1 upon x, right? So this is going to be simply equal to e to the power limit x tending towards infinity. Now I'm cancelling, I'm taking x as common, so then I have to cancel this x from the numerator and the denominator. It is going to be 1 by 1 plus 1 upon x, right? And you know that 1 upon x for x tending towards infinity, it is almost equal to 0. So with this you will have the answer as equal to e. So from here, this particular problem, the answer is going to be option number C. That is going to be the answer as E. Okay. So very simple problem. You just need to find out that alpha, oh sorry, very sorry, alpha is going to be E, right? Extremely sorry, alpha is going to be E. So we have alpha, the value of alpha as equals to E, right? And then we have to calculate the expression of log of alpha plus 1 by log alpha. So this is going to be equal to, so log of alpha by 1 plus log alpha, right? That is what we have to calculate out. Right? So let me check if I have any mistake or not. So let me check. Oh yeah, I forgot to multiply with e into 1 minus e, right? So this is going to be, there is blunder over here. So let me multiply that e into 1 minus e part. Okay, that is going to be e into 1 minus e over here. So I forgot to write that. So that is going to be e into 1 minus e. So therefore it is going to be e to the power e by 1 minus e, right? So alpha is going to be e to the power e by 1 minus e. So from here, if you try to put that alpha back into the expression, that is this alpha. So I can also write this particular part as 1 minus 1 upon log of alpha plus 1, and then this part is going to very simplify part out as it is going to be 1 minus e by e minus 1, and from this part you are going to get the answer as 1 upon minus 1 up by e minus 1 by e minus 1, right? This is going to be the denominator, and so let me check it again, and then this particular part. Okay, so yeah, actually did a mistake. So this is not the correct expression. So what you can do, you can directly try to put the value of this expression over here, right? You're going to get the result as e by 1 minus e divided by 1 plus e by 1 minus e. And if you try to simplify this part out, you're going to get the answer as e only. Okay, so that was a mistake. Okay, so please try to make sure that you do it correctly. So therefore your expression of log of alpha or natural log of alpha by 1 plus log alpha is going to be equal to e. So from here you will have option number C as going to be the correct answer for this particular problem. I hope this part is clear and making sense to all of you. Alright, so with this we are done solving all the important JEE Mains previous year questions on the topic of limit. Okay, now some questions you saw, the questions of differentiability and continuity was there taken up. So don't worry, I will take up especially the questions of continuity and differentiability in the upcoming sessions. Okay, so tomorrow we are going to come live again. We are going to discuss the topic of continuity and differentiability in tomorrow's class. So with this, let us end our session over here, and I have some homework problem for all of you. So this is one of the homework problem. Please try to take a screenshot of this particular problem. Okay, please try to take a screenshot of this particular problem and let me know the answer you're having in the comment section. So please mention the answer as the option in the comment section. I will be looking for your answer in the comments. Okay, so with this, let us end our session over here. So I expect that you at least got to learn things up in this particular session. Okay, so this session was especially helpful to those students who are basically have covered the basic part and they started to solve the questions. Okay, so please make sure that you write the short notes, you recollect the short notes and keep on revising the short notes. So that will actually help up in order to perform better in the examination. So with this, let us end our session over here. Thank you.